29 minutes and do 72 G signs. All right, who wants to do number 1? Nithya.
Figures 2 and 3. Least amount of recovery sleep and maximum lifespan. So if you look at figure 2, the Y with the least amount of recovery sleep was S minus S minus. So if you look at figure 3, that would represent the squares. So the maximum lifespan was 60 days, so it'd be A.
Good. So you go figure 2 and 3. Look at what had the least recovery, which is this one. Always read your axes, and this is the amount of recovery sleep. All right. So that's S minus S minus, and that takes. Then you go down here and see which one had the least lifespan, which is 60 days, which is the S minus S minus. So that should give you 60 days, which is A. All right. Number 2. On to number 2.
Figure 2, amount of recovery sleep, S plus S plus, and how many times greater, and S plus S minus. And then I looked at so S plus S plus is like about 90, and then the other one is like 60, so that's about 2 times.
Good. All right, so what you do is you round this up to 120. That's 120, and you put that over, what is this one? This one is about 60. That's roughly 2. All right, you get F for that. Number 3. Rohit?
You underline figures 1 and 3. Average of 12 sleep events per day. Percent that had reached 35 days a day. And I got C for this one.
Okay, how'd you get this?
You look at figure 1 and see like which one got 12. And then that's
So when we have a figure with 2 charts still, what's the first step we always do? Read the axes, right? So which chart am I even looking at?
The one on the bottom.
Good, because that's the number of sleep events, which is the one I'm doing. The top one is sleep per day.
Yeah. And so the one with 12 was S minus S minus. And if you go to figure 3, you go to 35 days and go to the one, the line with the squares, go up, and there it's 25%.
Good. So you go right here. This one had 12. Follow the S minus right up for 35 days. Draw it over to the y-axis. You get around 25%. That should give you C. All right, number 4. Sid.
Underline figure 1. Amount of sleep every day. S minus S minus. And then percent of. And then S plus sleep per day. Alright, and then so you go to figure 1 and you see that the S minus amount of sleep per day is 100 minutes.
Where are you in? Figure 1?
Yeah.
Okay.
Or am I right?
Yep, you're right.
And then you round up S plus to 1,000, and then 100 of 1,000 is 10%. So
Perfect. All right, notice how you rounded this right up to 1,000. Do that. Don't nitpick on like 900, try to do 100 over 900. All right, that's good, and that is F 10%. All right, number 5. Nithya.
Type S plus crossed with S minus figure 3 and alive at 50 days. So if you cross an S plus
Can you tell me what your answer choice was that you got for this first?
D.
Okay.
So I crossed S plus S minus, you get S plus S minus.
Okay, can you walk me through how to do a Punnett square? How many people here have done a Punnett square before? Ruin, you've done it? Amitesh, yes? Hey, what about you, Venkat? Alright, so it's everyone. So Nithya, explain it again to everyone just to recap.
So you put S plus on top, and then you put
Whoops.
And then if you cross them, it should turn out to be plus minus. Yeah, so you get all of them would end up being.
This is not right.
It'd be plus plus on the top.
Yeah.
And minus minus, and then the inside would be plus minus. So all of them would end up being heterozygous. So if you look at figure 3, it should be the triangle. So if you look at 50 days, it's approximately 75.
Okay. Did anyone else get anything else for this one? Anyone? How many people here put C? How many put A? First, let's start with A. B. Raise your hand nice and high if you put anything. C. How many people put C? Nice and high. You put C, right?
No.
Or no, you put D. You who put C? Okay, and then D. Okay, Lauren, why don't you explain why it's C?
I just didn't do
Okay, Venkat, how'd you get C? Okay, well you got to do a Punnett square regardless. That's, Tej, why'd you get C? Okay, so how did you guys get the right answer without doing a Punnett square? Explain that to me then. So, Lauren, explain what you did then.
Listen. Okay. Sorry.
Tej, how'd you get C?
I didn't know if I just
Okay. D is not the right answer. This is the most, like, you guys just missed over a key detail, okay? Right here, 80 offspring, okay? It says, let's see. It's the number of these offspring. That's the key word, number of 80. Okay, so let's go through what they're asking here. Suppose that a fly with a genotype positive is crossed with a genotype of minus, resulting in 80 offspring. Okay, based on figure 3, the number of these offspring still alive at 50 days would be what? Okay, so we have all of them are plus minus. Let's write down everything we know. And at 50 days, what percent is alive? Okay, so if we have positive minus, let's go here and see which one are we supposed to be looking at? Well, Nitya said the triangle. Okay, so let's go up to 50 days, which is right here, and draw it right up to the triangle. What do we get? Who can tell me what percent this is? Yep, let's draw it right over. And what is the key word I just said? Yes, and what is this thing say right here? Percent. Okay, so if we're 75%, what is 75% of 60? Or of 80, because that's what we're dealing with, right? We're dealing with 80 total offspring. We want to know, this is the percent survival. So if the percent survival is not 100%, some are going to die. So, good. So of those 80, some are going to die, and only 75% are going to live, which is 60. Hence the answer is C, not D. Does that make sense to everyone?
So why did
You guys stopped right here and chose 75%. The key words you always need to look for are percents and averages. Because you will always get messed up when you see those two words. The Punnett square, you need to know what your new genotype is, because they say a positive is crossed with a minus and a minus. So how do you know in this one which to look at? You need to know what their kids are going to be. Is it a minus, positive minus, or minus? Yeah, you don't need to draw a Punnett square, but for someone who doesn't know how to think of that in their head, draw it out. Does that make sense to everyone? The answer is C. All right, let's go on to 6. All right, number 6. Who wants to do this? Kritika.
Figure 3, H equals 12, offspring X, most likely.
Why do we need most likely? Or closest? Remember, we're trying to underline numbers and figures. We don't care about most likely, because anything we underline is what we're memorizing. So right now, memorizing figure 3, H equals 12, and X. That's it. So I'm going to go to figure 3, and I'm going to look at what?
H equals 12.
Good. And then I'm looking for?
What the Y is going to be.
Good. So at figure 12, what is it?
Yeah, I said it was H.
Good. So it's about 6, because all you do is you just extend the line, crosses around 6. All right, 7. Rohit.
Underline spring belly, same procedures, other day spring, stick stiffness of spring W is much greater than spring X, Y, or Z. Figure 2 for H equals 4.0. A over G, and I got B.
Okay, can you walk me through how you chose that one?
I looked at so the stiffest spring was spring Z, and that's the one with the triangles.
How do you know it's the stiffest?
Because I looked at the passage.
Okay, where does it say that?
Look in the second paragraph.
Good, right here. Spring X is the least one. Spring Z is the stiffest. So, least is X, most is Z. All right.
And then this new one is more stiff, so it should be higher than 5.
Perfect. So we go up to 4, draw up our line right to the triangle, see what it is, it's 5. So it needs to be greater than 5, because if you look at the order, it goes least, medium, most stiffness. And if the new spring is stiffer than the stiffest, it's going to be above it. So the curve for this one should hypothetically be somewhere along that. And it would be greater than 5. So that's D. All right, 8. Manvita, number 8.
Underline spring X, maximum now, and 3,000 and then you look at figure
What are we looking for, though?
how far,
Good.
and then you look at figure 4 and then go to 3,000 and answer on 4, so that's B.
Yep, that's, you got J, right?
Yeah.
Okay, good. J, it's 4 below the original position. All right, 9. The acceleration due to gravity is approximately 10 meters per second squared. Based on figure 2, when H equals 8 for spring Z, what approximately is A? All right, so we know gravity is 10. We're looking at figure 2. H is 8. We're looking at spring Z. What is A? All right, so we're going to go over to figure 2. We're looking at H equals 8 for spring Z. So we're right here at the triangle. So we have 8. We have A over G is equal to 7. So who can do this one? Sid.
So A over G is equal to 7, right? So we're given G, right? So A over 10 equals 7. So A equals 7 times 10, which is 70.
Good. Acceleration is equal to 70. Perfect. Does everyone get how to do that? All right. Next one, 10. Who can do this? Varun, do number 10.
Underline H and the object's acceleration greatest, and then off of the spring, and then distance y meters, and then initial position.
All right, guys. This one you're not going to find anywhere in the passage. It's use this equation. F equals, remember, you always use the biggest equations for whatever topic you're studying. You're studying physics in this one, okay? F force is equal to mass times acceleration. All right, they want to know why for a given h is the object's acceleration greatest when the top of a spring is what? So if a is your greatest, so if you have a high a, what needs to also be high? Yes, your F also needs to be high. So it's G. Another way to figure this out. Go here. As the distance below, look at this. What is y measuring? Y is measuring the distance below what the original position was. So if I have a spring here and I'm compressing it, my y is getting bigger. My y is my distance from the original position. If the distance from the original position increases, the force is increasing. Because as I compress a spring, what happens when you let go? It bounces back up, right? So the more you press a spring, the more force it's going to have and the more it's going to push back. So why is that? Why is the acceleration the greatest? It's because the force is the greatest. So that's G. All right. let's go on. We're gonna start speeding through this, all right? Number 11. So you can go to according to figure 1 at 45 degrees, the air temperature at Earth's surface is closest to what? So I'm gonna go to figure 1. 45 degrees is my solid line, and I'm gonna go to Earth's surface. What? Good. At 0, what is it, Sid? Good. You know it's got to be between 10 and 20. Don't try to analyze and see what exact number it is. Just choose. There will only be one answer between 10 and 20. Number 12. According to figure 1, the air temperature at 0 degrees is the same air temperature at 45 degrees at which altitude? So what are we looking for? Between those two lines, what specific point? Good. The intersection point between 45 and 0. Which at 45 is the solid, 0 is the big hashed one. So when is it? It's somewhere right here between 12 and 15. Which one's the only one between 12 and 15? 13. Good. Now 13. Figure 1. The average troposphere altitude for 30 degrees would most likely be what? Alright, so we're going to go to 30 degrees. But we don't have a 30 degree. So, based off the trend, what is the trend? Always follow trend for... They always are analyzing trends whenever they ask you for a new number. So you can see it's increasing as you go down. It's going 0, 45, 90. So where should 30 be? In between 0 and 45, right? So where's the average troposphere for 45? Well, it's somewhere around, what is that, like 10. And then for 0, it's somewhere around 16. So it's between 10 and 16. Which one is that? That's closest to C. All right, 14. Based on figure 2, was the average troposphere pressure inversely or directly related to the altitude? All right, so we're going to go to figure 2, and we're looking for pressure and altitude. All right, so whenever we have more than one chart in a figure, we always read our axes. This is temperature, pressure, altitude. Which one are we dealing with? We're dealing with these two. What does it mean when it's directly or inversely related? Directly means as one goes up, the other goes up. So right here, these two are directly related. As the months increase, both of them are increasing. Does that make sense? So as one goes up, the other goes up. However, what are these two? Inversely. Good. As this one goes up, this one's going down, and vice versa. As one goes up, the other goes down. So they're inversely. So first thing we do, we always look at the first word, and that tells us our answer. So it's not directly. Now let's read the explanations. So inversely, because from January to December, as altitude decreased, air pressure decreased. So from January to December, from January to December, what happened? As altitude increased, did air pressure decrease? This is too much for me to even read. Who wants to do this one? I don't feel like reading it. Nithya.
Altitude decreased and air pressure increased.
Yeah, what she said. This is too much for me to read also. It's there. Okay, if you do the question, you'll figure it out. 15. Alright, according to figure 1, at 0 degrees, how does the air temperature in the troposphere change with increasing the altitude from Earth's surface to the troposphere? And how does air temperature in the stratosphere change when increasing the troposphere to 27 kilometers? Okay, there was a lot we just read. So what's the main question here? Yeah, so at figure 1, I mean, we're going to the 0 degree one, which is this hashed line right here. And they're saying from...
Is the where like they break apart from like one line to another line? Is that the line between the tropopause and the stratosphere?
So whenever you don't know the definition of a word, look it up right here. Just glancing at it, they even italicize it. The layer just above the troposphere. Make sense? So that means it's whatever's above the troposphere. And they even tell you in the question, it's from the troposphere to 27 kilometers. That is the definition of the stratosphere.
So that's the stratosphere, and then everything below that is the stratosphere.
Yeah, so what are they varying? How does air temperature vary with increasing altitude?
So then isn't it just D?
It is, yeah, it is D. So how you do it is, as you increase altitude, so as I'm going higher, what is happening to my hashed line? It's the air temperature is decreasing all the way until my troposphere. But then, past my troposphere, now I'm in my stratosphere, what happens? It's now increasing the temperature. So it's decreasing, then increasing, so it's D. All right, before we start this, we're gonna go over osmosis. If I have a cell, and say this is a cell, and say these dots represent salt. Let's say I have a lot more salt right outside. What is gonna happen? And then say I have another cell, except this one is filled with salt inside, and there's just a few dots out here. What is gonna happen? Diffuse which way? So what's going to happen? Where's the water going to go on from the cell? Out. Good. So water is going to go outwards this way. All right. Then here, what's going to happen? Where's water going to go from? Yeah, from outside to in. Okay. So water is going to diffuse into there. That's all you need to know. And just remember, it's going to diffuse this part, dilute this part to be the same concentration as inside. That's the basis of osmosis. All right. You need to know that to answer this passage. 16. Suppose that in experiment 1, the students had also tested a 70% honey solution. What would the percent change in mass be? Varun or Sid? They'll look the exact same. Okay, Sid. Alright, let's go, come on.
60 and 80, between that is 70. So the percent change would be 45 and 77, so it'd be between 25, so it'd be H.
Good. So it is H between 45 and 77, because what are we looking for? The 70% solution. So that's right in between 60 and 70. So that's right in between here. So that's 45 and 77. All right. When the students added the samples to bags in experiments 1 through 3, they only partially filled the bags. Most likely reason for this is the students wanted to allow room for H2O to enter the bag. Why would they leave room if it's going to exit the bag? That's a common sense question. Now these two, they make absolutely no sense. So cross both of them out. You're left with A is the only logical answer. And you know you're dealing with osmosis if you actually didn't know you're dealing with osmosis. This is the only sound answer choice though. In experiment 1, did anyone find the answer to this in the passage? Okay, yeah, because I couldn't. All right, 18. In experiment 1, to make a 60% solution, which of the students mix which two? So if they made a 60% honey solution, how proportions work is you put your part over your total. So if I have 6 milliliters of, I want to get a 60% honey solution, I obviously need a 6 on the top. What would I need on the bottom to get 60%? 10. All right, which two add up to 10? H and J, right? Or no, G and H. G and H add up to 10. The F adds up to 8. J adds up to 12. So these are the only two that add up to this. G would give me a what? 40%. We want 6 on the top because so it would be H. Why did I cross that out? It should be H. All right, 19. According to the results of experiment 1, for the 40% honey solution, did the mass of the solution in the bag increase or decrease as a result of the bag having been submerged, and why? Who wants to do this? Amitesh, 19.
Experiment 1, 40% honey solution. Yeah. So you go to table 1, at 40% honey, you can see that the initial mass and the bottom mass, they increases. So it would be either A or B. And
What did we learn in the beginning? So let's apply that to here. So we know it increased. So C and D are out because if we go to 40%, it obviously says there's a percent change in mass. They're all positive. So they must have all gained mass. It gained 32% in mass. So it obviously increased. So why is that? When does water,
Could be,
I don't know, is it?
yeah,
Why is it B then?
because it's a higher solute, H2 all into the bag.
Yeah. So which out of which these two, this would be the bag, so it had a higher solute, so water is going to come in. So if water comes in, we're increasing the mass of it. Does that make sense? All right, 20. So based on the results of experiments 1 and 2, the concentration of honey sample in company Y would most likely have been what? So we're going to go to company Y. It's got an 85%. Who wants to do this actually? This is a good question to do. Brune. Number 20.
The underlying experience 1 and 2, and the concentration of honey and company Y.
Okay. They said use experience 1 and 2, so I obviously need to take some information from both. Who can help them out? Nitya. No, it is not. Venkat, help him out. Yeah. There are glasses right there. The fridge is right there. Don't go upstairs. Alright, Venkat, while you grab water, explain this to me though. Number 20. Meghna, number 20.
Okay, so I said it was H, that it was greater than 80% but less than 100%. And the reason I said that was because in the percent change in mass, if you look, 80% has 77% change and 100 has 95. And if you go to table 2 and to the company Y, you see they have an 85% change in mass, and that's between these two.
Good, so if you look at this one, it has an 85% change in mass. Go down here, 85 falls right there. That's between 77 and 95. That's closest to H. All right, 21. In experiment 3, who wants to do this one? Sid, 21.
Alright, experiment 3. One of the bags decreased and then submerged. So you go to experiment 3. I got C.
You got C.
Yeah.
Why? How'd you get C?
I think that's
All right, we don't guess though. Let's think this through. So the mass decreased, right?
Yeah.
So let's use osmosis. If we have a bag right here, when is it ever going to decrease? Which way should the water go out if it's decreasing? If the mass is decreasing, the water should go out, right? When does water go out? When it's more solutes out here or more solutes in here? In here. Water goes out? Are you sure? Okay. Remember, whenever you have, let's go over osmosis again. Osmosis, just think you want to dilute the more solute, more concentrated stuff. So water is going out of here to dilute this down. Water is going in here to dilute the inside part. So if I have water coming out, which part is it trying to dilute? The outside. Yes, that means there are a lot more salts out here. Okay, so it's obviously going out. Which one up here would have the highest concentration of solutes? 100%. That's it. Yeah. Yeah, you can go sit down over there. Oh, you do? Okay, yeah, go for it. Yep. Watch the videos whenever you start feeling better. Okay. Let's go over the rest of this. All All right, 22. You know what? Actually, we're not going to go over questions anymore. We're going to only go over questions you guys want to now. So I'm going to read you guys off the answers because we're into the point in class where we need to start going over a lot more sections. We are only going over 2 sections per day, and that's not enough. So I'm going to start off 22F, 23B, 24G, 25A, 26H, 27D, 28J, 29D, 30F, 31B, 32J, 33A, 34F, 35B, 36H, 37A, 38F, 39C, 40J. Okay, if you got any of these questions wrong, those who ask questions are the ones who are going to do better. Okay? There's this one saying, someone who asks a question is a fool for 5 minutes. Those who don't ask questions, though, is a fool forever. So if you leave this class with a question but you're too embarrassed to ask it, you're going to say stupid forever. But those who ask the question, they'll learn from it. So, who has questions? Brianna. Okay, let's go over that. 23. The clamp that fastened a strip to the ring stand was electrically insulated from the strip. This insulation was most likely needed to what? Okay, so this is dealing with the diagram, so let's go and look at that. So they're saying, why was this clamp insulated? So let's go up to the top. We can obviously see that current is flowing through this strip. And there's a voltmeter right here. So if I had electrons traveling down the ring stand, wouldn't that defeat the purpose of measuring the voltage on the strip? So this is kind of an intuitive question. You might be able to find it in the passage, but I don't think you can. What do we think the answer? What did you put?
I put A. I was I got confused between A and B.
Okay, so to prevent this from entering the clamp would stop it from ever flowing down the ring stand. However, if we insulate this, it's just going to flow here. So by uninsulating this, electrons can now flow down here. So that's why your clamp would always be rubber here, because rubber is non-conductive. However, if it was metal, your electrons would travel down here. This voltmeter would read a different reading every single time. Some electrons would go down here, some would go on the strip. Does that make sense? Okay. All right, who else has a question? Nithya. 25. Okay. So, suppose a new trial were conducted using the... What's wrong with this sentence right here? English-wise. Good. Even the ACT messes up sometimes. Okay. Everyone see that? Please tell me we at least learned what was versus were is. Okay, singular versus plural. Okay, suppose a new trial was conducted. We're just going to fix that right now. Suppose a new trial was conducted using the procedure from trial 1, except that B is equal to 0.2. Based on the results of study 2, VH would be what? Okay, so we're having a new trial based on what was done in trial 1, except B is now 0.2. So B is 0.2. Is it 0.2 or 2? Yeah, 0.2. And we're doing it based off trial 1. Okay, so whenever they say to use two studies, you're always going to look at trends, okay? So what trend should we look at here? Well, we should see what happens when I increase my B. What's happening to my BH? It's increasing, right? So as B goes up, V goes up. All right? Look at my standard in trial 1. Where are the standards? It's always right below whatever study you're looking at, right in this little paragraph. So the standard is B is 0.6. So what was the difference from 0.6 to 0.2? Increase or decrease? It's a decrease. And what do we learn? They are directly related. So if I decrease my B, what is going to happen to my V? Decrease. So it should be less than 13, right? Which is A. Does everyone see how I just did that? Does that make sense to you, Nithya?
Well, like, how did you know it's less than 13 but not less than 11?
Because
It says this is 25, which is
So what they're gonna do here is we went from 0.6 to 0.2. So what happened to my V? I went from 42 to 11. But don't focus on the numbers, just know that you decreased. So if I decreased from going from 0.6 now to 0.2, my new trial is with 0.2, it should always be less than 13, right? Does that make sense? Okay. Makes sense to everyone. Mandita.
Aren't you supposed to look at like when B is 0.2 to 11 and 11 is less than 13?
You could do that too. Yeah. One sec. No, you can't do that. Because this was done at I equals 25. This was done at I equals 10. We're not changing our I. We're changing our B. So we're just looking at the trend of B. Okay? That was, but you got it, so it might be luck that you got that. It might work out next time. Just look at the trend though. All right? Next question. Who has any more questions? Lauren.
I'm sorry.
Yes. Easiest way to explain this, when I have y equals, let's say mx over b. Nope. Yeah, we'll do that. All right. Actually, no. Whenever two variables are on top of each other, that means they are directly related. The easiest way I remember this, when they're dividing, they are directly. When they are multiplying, they are inversely related. That is the easiest way to think of this. So if I look at, so the first thing I need to do, forget about that. First thing I need to do, I need to go look at all three of my charts. So as I goes up, as I increases, what happened to V? V increases as well, right? Okay. Then as B increases, what happens to V? Good. And then as D increases, what happens to V? Decreases. Okay. So that means I have two direct, B and I are direct. So my direct are B and I. My inversely related is what? My D. So if I want two direct things, they need to be on the bottom, right? They need to be dividing by each other. So which one of these divides the V and H? By the easiest way to do this, the answer is D. I'm just going to show you how you rearrange this equation. I multiply both sides by D. So you get dV is equal to KIV. Then you divide both sides by V. So you're left with D is equal to KIV over V. Notice how they're dividing? B and I are dividing by V, which means they are directly related. However, D is on the other side, which means it's inversely related. If you guys ever follow the equation, you might learn this later, it's PV equals PV. Those two, how are PV related? How are they related though? Directly, good. And then there's another thing, PV equals nRT. How are P and V related in this case? Inversely, good. That's the easiest way to remember this. All right, next passage. Who has questions on this? Ask them now, because I know no one here got 100%. Brianna.
30.
All right, 30. Which of the following unbalanced equations is most consistent with student 1? All right, let's go see what student 1 was talking about. All right. Let's see. Which line tells me what his philosophy was? Nope. Nope. Good. The wax fumes act as a fuel that reacts with the O2 present in the air. So what's reacting? Fumes plus O2. And if it's yielding a fire, what does a fire always give off? CO2 plus what? Yeah. All right. Which one is that? Good. If someone put G, which one did they get mixed up with? student 2. Good, because he said it reacts with N2. If someone put, I wouldn't even know how you'd get those two, because I don't know what CN is, and then you don't get, if you're lighting a fire, you don't get any of those. Does that make sense? Okay. 31. Or no, who has any more questions? Not on this passage? Alright, let's go on. Last passage. Don't be embarrassed to ask questions, guys. Brianna.
30.
Alright, according to results of study 2, in which of the following did the C content change the most from a depth of 0 to 2? Okay, if we're looking for something that changed the most, what are we looking for? In study 2, which one study 2? This one. We're looking for the wrong one. In study 2, we're looking for the C content that changed the most. So which one should we be looking for? We should read our axes. This is C content. So should my line go vertically or horizontally if I wanted to change the most? Horizontally. Which one goes most horizontally? Out of this site, this site, or this site? This one. Okay, out of this one, which one went further? Grass. Okay. So, okay. Did you look at this one?
No, I think I got the grass and the shrub.
Okay. Okay, yep. So the easiest way to do this would be to figure out its site X, cross out Y and Z, and then you're left with these two and differentiate between grass and shrub, and which we know is F. All right, any more questions on this? Lauren? All right. In this statement, some shrub roots penetrated more than 1.5 down into soil, consistent with study 1. All right, this confused the hell out of me. Where does this chart go? But this chart is with study 1, and then this is with study 2. So in study 1, if I'm looking here, and I want to know, did shrubs penetrate farther than 1.5? I want to know, did it go greater than 1.5? Well, let's look in this chart. Okay, this is annual precipitation. I don't care about that. What is this? This is 95% root mass depth. Okay, so what am I looking for? I'm looking for shrubs that went more than 1.5. Well, what is shrubs right here? 1.6, 2.4, 3.3. That's depth in meters. So it went 1.6 meters, 2.4 meters, and 3.3 meters. Aren't those all greater than 1.5 meters? Okay. Okay, so you got no, so it should be yes, because they are all, is it greater than 1.5 or less than 1.5? Okay, remember I said, there's always one thing in the beginning, which is a yes, no's that are different, and there are always a few other things in here that is different. Always vertically analyze these questions. You can see right here, if you vertically analyze, this is greater, less, greater, less. This is the people who get 36 are the ones who can pick up on this and quickly realize the differences in these answer choices. So get quick at doing that. Anyone else have any last minute questions on any previous passages? Because we're never going back to that again. Okay, so take out your reading.
Are we doing another passage now?
What's that?
After reading?
Yes, we're going to do something after reading.
What?
Math. So everyone start bringing a calculator from now on. Jason. Is he asleep? How do you want him to take the time for a reading?
Reading,
You want him to do the whole thing or in parts, like half and half?
like right now,
Yeah,
just do the whole thing.
whole thing. Okay. How long? 30?
Sure.
Okay, 30 minutes it is. So that's 7.5 per passage. That's 4 minutes of reading, 3 minutes of answering questions. And that's 30 seconds to bubble. All right, you guys can start.